Hi everyone. In this lecture I'm going to be talking about how you can use the built-in find function or find method on arrays in JavaScript to find the first integer for which some property is true, or find the index of the first item in an array or the first character in a string. I'm going to be going through a number of examples. So first let's start with trying to get the first integer that's divisible by d that's greater than or equal to start, right? So to check if a number num is divisible by d, we would just check if num%d equals 0, which means the remainder when you divide num by d is 0, right? And we want to actually make sure it's greater than or equal to start. And we know that for any positive integer d, there's going to be a number or an integer between start and start plus d where num will be divisible by that number, right? So including start, excluding start plus d. So this is what our function would look like here. So you see range start to start plus d. That's going to be the array that we're checking, and then we do dot find, right? Num arrow num%d equals 0, right? So we're passing this function here, or passing the reference to this function, this Boolean valued function that returns true whenever num is divisible by d. Right, so let me just give you an idea of how this is going to work, and specific numbers here for start and d. So let's say we have a start of 42 and a d of 10. What I was basically saying before then is there must be an integer from 42 to 42 plus 10, right? That's your start plus d, that will be divisible by 10, right? And again, including 42, excluding 52, right? So we're going from 42 to 51. So there will be such an integer, right? That integer will be 50. So how is this going to work here? So what we would do is we would actually be, if we called first divisible by d find, and we plugged in 42 for d, and 10 for d, and 42 for start, right? It should log 50, right? We were looking for the first integer that's greater than or equal to 42 that's divisible by 10, and you can see how this is going to work. So first, range 42 to 42 plus 10 is going to generate the array 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, right? So it stops one before the ending number that we give it, which is fine because we said that there would be a number that's divisible by 10 that's less than 52, and that's also greater than or equal to 42. So the way it works is it takes the first number in this array and it plugs it in for num, right? So that's the input that is used first. So you can see we have the 42 is plugged in, 42 is plugged in for num, and it checks is 42 divisible by 10, right? Is the remainder when you divide 42 by 10 equal to 0? And that comes up false. So what it does is it then goes to the next number in the array, which is 43, and plugs that in, right? So now it's checking is 43 percent 10 equals 0, right? So it's 43 divisible by 10, and it's not, right? So then it goes and plugs the next one from the array, 44, and it keeps going, so 44 is not divisible by 10, so you also get false, and it keeps going until you get a number that you plug in, 50 in this case, where this evaluates to true. And whatever that input is, whatever that first input that you get that produces true as an output here, is going to be what find gives you back, right? So first divisible by d find, 1042, 10 is going to go in for d, 42 is going to go in for start. We plug the 42 and the 42 plus 10 here, or 42 for start, d for 10 for D, so we get 42 to 42 plus 10 for range. It's going to go through the process that I said. So this whole thing is going to return 50, which will be the output from this function. So it's going to log 50. All right, so let's look at another example where we could use find here. So let's say we want to find the binary log of an integer power of 2. So an integer power of 2 here, what I actually mean when I say integer power of 2, not that we're using an exponent that's an integer, we're just actually getting a power of 2 that winds up being an integer. So what I'm saying is like, we're not doing something like 2 to the negative 1. Negative 1 is an integer, that would give you a half, right? So a half is not an input that you would be able to use. What I mean is that when you do to 2 to that power, you're going to get an integer, right? So that could be 2 to the 0 where you get 1, or 2 to the first where you get 2, or 2 squared where you get 4, etc. So if you want the binary log of such a number, you're really just looking at the exponent that you raise 2 to get this number, right? And since we're only going to be considering integers that are powers of 2, all of them are going to be able to be expressed as 2 to some integer greater than or equal to 0. And so we're just going to get that integer greater than or equal to 0, that d that 2 was raised to. So as an example, if you had the log of 8, right, 8 was an example of 2 to the third, so the binary log of 8 is 3, right? The log of 1024 is 10, since 2 to the 10th is 1024. So another way of actually thinking of the binary log is for powers of 2, it's the number of times you can double from 1 to get to that number, right? Or you could think of it as the number of times you half the number to get down to 1. So just as an example, 8, the binary log of 8 is 3, because if you start with 1 and you double 3 times, you get to 8, right? So 1, 2, 4, 8. You could also think about it as halving, so 8, 4, 2, 1, right? So in both cases, you get 3, and that's going to be what the binary log of 8 is. So if we're actually trying to think of where we should start, or if you're actually trying to think of how you would solve this problem of finding the binary log, you could ask, well, I mean, it's given right here, does 2 to this power equal x? And what would you start checking with? You'd start checking at 0, right? Because you know that your number is going to be 1, right? Or 2, or 4, or 8, right? It's going to be greater than or equal to 1. So the d that you're going to have to use here is going to be greater than or equal to 0. So you repeatedly plug in numbers 0, 1, 2, 3, 4, 5, 6, etc. until you get the, until 2 to that number is equal to your input, right? So that tells you where you want to start checking. You want to start checking at 0. Where can you stop checking? So you could just see a little algebra here. You could actually stop checking at x minus 1. Generally, you could stop checking at a lot smaller number. So for instance, if you wanted the binary log of 1024, it's certainly going to be less than or equal to 1024 minus 1, or 1023, right? Because you know that 2 to the 1023 would be greater than or equal to 1024, right? As I said, this is a much larger number. 2 to the 1023 is much larger than 1024, but it's just an upper bound or a place that we can stop checking, right? So if you want to stop checking at x minus 1, right, you can just remember that range is going to stop checking 1 before whatever you give it. So you stop checking at x, or you put x here, and then it'll stop checking at x minus 1, right? So you're going range 0 to x, right? And you repeatedly want to plug in these values for d. So if your input variable here is num, you repeatedly want to check whether 2 to the num is equal to x, right? And then num will be 0 first, and then 1, and then 2, etc. So just as an example, if you're doing the log of 32, right, 32 gets substituted for x. So you go 0 to 32 here. I didn't actually write all the numbers here because I originally had 16. But what this would do is it generates range 0 to 32 would generate the array going 0 through 31, right? And again, since we have dot find num arrow num percent, wrong thing again here, typo again. Got to stop copying and pasting. But if you're going num arrow 2 to the num is equal to x here, it's going to repeatedly plug these values in, right? So it's going to check first 0, and it's going to check does 2 to the 0 equals 16, and it doesn't. So then it's going to plug in 1, which is the next number in this array. So then it's going to check does 2 to the 1 equals 16, and that's also false, right? And it keeps, and I should say 32. Maybe I should totally redo this slide and redo this presentation, but I'll just say right now it says 32. We'll just pretend it says 32 so I don't have to go back to this here. So it checks whether 2 squared is 32, right? And it's not. 2 to the third is 32, and it's not. 2 to the fourth is 32, and it's not. And finally goes to this last one of 5. So it plugs in 5 here, and it checks whether 2 to the 5 is equal to 32, and that's true. So it would output 5.